Hello everyone, and welcome back to this multiple app workflow tutorial on Cinema 4D and Softimage. In this chapter we're here in Faceshift, and we're going to be using Faceshift here to capture the motion capture that we need to drive our face robot. So Faceshift is a program designed to allow you to capture facial motion with the Kinect and basically create a virtual avatar. The idea is that you capture these poses, as you can see here, and then they can be used to drive blend shapes. The great thing about Faceshift versus Braille Connect is the fact that you can save out C3D files, which have all the Faceshift markers available in Face Robot without any issues. So here in Faceshift, you can go into the setup mode here, and you can see how your camera's doing. You can see how the depth is coming along. You can zoom in. You can use your left mouse button to go ahead and pan around. Make sure you've got a good depth. I'm actually running this on my Mac using Boot Camp for Windows 7, so I'm not actually looking at my Kinect level, but if I were to raise my head a little bit, looks like I've got a pretty good shot. It's doing a pretty good job of picking up my face. Alright. You can also see this in depth map mode, so you can tell how close your face is to the camera. You can also see this in point cloud, which is a very similar interface to Reconstruct Me. See all your point cloud data and see how the camera's picking up and reconstructing your face as a mesh. Seeing the surface in video allows you to have another view of what's going on in your scene as well. Just like in Braille Connect, I'm probably going to have to remove my glasses to get a good sensor read with this program. Now with Faceshift, we only have to scan in this neutral pose to actually be able to drive an avatar when we click Build. However, creating all of these blend shapes is going to allow Faceshift to better accurately represent a virtual avatar for your face, and thus you'll get better marker data in the end when you go into Softimage and use this marker data. Alright, so we're going to scan the neutral pose, and basically what you would do is you hold down on the capture button, and it's basically going to allow you to go in a la Reconstruct Me style and basically gather up data to represent your point cloud. You're going to want to keep your face kind of still and kind of in this nice neutral pose that they're giving you right here, and then you're going to want to just move your head around and let it pick up all the data so you have a nice clean topology for it to pick up. So let's go ahead and try this. I'll take off my glasses, and this is actually really nice that I'm doing this on the laptop because I can actually get a little bit closer to the screen and be able to actually really see what I'm doing. So anyway, as you can see, I'm moving my head around, and I'm probably not going to get a good read in this particular case because I'm talking as I'm moving my head, but I'm basically trying to get a really good read with no holes. Alright, so let's try to do this right this time. I'm going to hit rescan, and we're going to hold it and put my face in the neutral pose. And that didn't come out well. It's probably because it lost my face during the scan. Let me get in closer to the camera or get further away from the camera. and let's try to rescan this pose. Beautiful. That looks great. Alright, and then we'll do one more pose. This is the open pose. And unlike with Reconstruct Me, I'm not really moving the connect. I'm just moving my head around to allow the connect to get different angles of my face. Alright, so I'm going to pause the video. I'm going to go ahead and get the rest of these poses to get a kind of good map of my face, and then we're going to go ahead and try to build a profile. Alrighty guys, so we got all the poses, or blend shapes, and at this point what we want to do is we want to go ahead and click on build, and it's going to go ahead and fit our avatar's face, our default avatar, to match our face. It's going to ask us to adjust the eye positions to make sure that they're right, and this looks about okay, so we're going to hit OK. And it's going to go ahead and just fit all these poses. And it seems like this program was created more as a virtual assistant type thing, but we can use it with animation program like Softimage or Cinema 4D or Maya or 3ds Max to basically drive our animated figures. It works about the same way as Brickle Connect, except it seems a little bit more powerful because it gives you a lot more marker data. It also gives you a really great reconstructed face. You can actually bring FBXs into this program and animate your animated characters, blend shapes, using this program, driving their animations from your facial capture directly. There's also plugins which will allow you to use this program with Motion Builder or any other package and basically send the facial data directly there. Alrighty, so this is almost done. I'm going to pause the video and we'll get back once it finishes. Alrighty, so it finished, and basically now that we went through all that trouble to create this profile, since it matches our face or whatever actor we're deciding to use this animation on, let's go ahead and save the profile out. And I'll just save it to my documents now, and later I'll move it via the network to the to our main machine for consolidation. But we'll call this Eldarin actor profile. This will basically be the profile for me. Once again, with this program, you're basically going to create a actor profile for each actor that you're going to have in your production. You can't use the same profile for different faces, so each actor is going to need to go through this setup, this initial scanning, and a profile is going to need to be created for them. There's going to be a similar process in Softimage, as we'll get into later in this chapter. It's also going to require separate face maps, but we'll talk about that when we get there. Alright, so we're going to go ahead and go to our admin folder, go to our documents, and we'll save it right here. And there we go. Now we can go to tracking, and now our avatar should follow our movements. We might need to move in closer on the camera. As you can see, you've got a camera tracking dialog here, this little bar that lets you know how close you need to be to the camera. I basically need to move the connect closer to me. During the actual scanning mode, I didn't really need it that close, but now it appears that I'm in a pretty good spot. The Connect is about 2 to 3 feet away from me now, so it's really close. If I take off my glasses, the avatar pretty much is following my movements pretty fine. I could probably improve the scans a little bit more to get a better motion track, but avatar is doing a pretty good job. So now what we can do is, let me go ahead and put my glasses back on so I can see. Now what we can do is we can actually go ahead and hit the record button to actually record a take, and then use that C3D data to drive our face and face robot. So what I'm going to do is hit the record button, and it's going to start recording the audio from whatever mic we have installed. And what's great about this program versus Braco Pro Face is the fact that we can also use an external mic. Right now I'm actually using my webcam's mic versus my internal mic here on the Mac. Alright, so I'm going to go ahead and take the glasses off, and I'm going to basically delete this initial recording. I basically stopped it by accident. So go ahead and right click and delete that, and then we'll go ahead and start the tracking up, and we'll go ahead and hit record. And alright, so this is a test. We are recording some facial animation with Faceshift in an attempt to basically have this animation drive our Softimage face robot rig. Alright, so that looks really good. Alright, so we're going to go ahead and stop the recording. And 686 frames. We're going to go ahead and we can save the recording so we can keep a track of the actual recording here in Faceshift, and we can also export the recording. Basically we want to export out a C3D file. Softimage uses these C3D format files to drive the face robot. Alright, so we're going to go to Documents, and we're going to transfer this over the network to the main project and use it. But anyway, this is going to be Faceshift _test take 1. And go ahead and save that here, and we can decide on which format we want to save this as, FPS wise. Let's go ahead and do a 30 frames per second. Do markers on the default face, and it's got a nice little marker set for face robot, which is exactly what we want. We want all the markers related to face robot. The problem with Braco Pro Face is you don't get all those face robot markers. You would have to do a translation to get Braco Pro Face's markers into Softimage. It also saves only as BVHs, so you have to go through a in my particular case, when I was testing this before, I went through a Motion Builder workflow. I basically imported the BVH into Motion Builder, and then in Motion Builder I trimmed down the timeline that I wanted, the exact markers that I wanted, and then I saved from Motion Builder using its export options to C3D, and then imported into Softimage. But the only problem with that is, of course, we still don't have all the markers that are related, and they're not very nicely named. There's some resources on the Autodesk website on what markers represent what parts of the face. And you theoretically could get away with using the markers in Breako Pro Face, but Faceshift gives you all the markers right off the bat, so pretty powerful. We'll also export the audio. You want the audio so that in the Cinema 4D workflow that I discussed with the Breako Pro Face tutorial, you'll be able to actually drive your audio, or rather, that was actually the Motion Builder workflow tutorial where I showed you how to drive the audio with the facial animation, how to load in the sound sample, and how to basically correct your animation to match the sound. So refer back to the Cinema 4D and Motion Builder multiple apps workflow if you want to look into how that worked. Here what we're going to do is we're going to go ahead and export, and it's going to go ahead and save our markers, and it actually crashed. It's beautiful. Alright, so I'll run through this again, and when we next meet we'll be in Softimage, and we'll be ready to start taking these markers and mapping them to what we need to map to get the motion capture to work on the face. Alright, so see you guys there. Alrighty guys, so real quick, we're here in Motion Builder, and I'm going to go over that Breako Pro Face workflow that I was talking about. So we're going to go ahead and open up a Breako Pro Face capture that we made, FBX file. And we're going to open up the first take. And if you zoom in on your scene, you can see that you've basically got your Breako Pro Face capture, and it's got the basic Breako Pro Face markers. Now, when we get into Softimage in a few moments, you'll see that the C3D file that we got from Softimage, or from Faceshift rather, has a lot more markers than this. But these are the basic markers that come with Breako Pro Face. We go into our scene here, and in our reference we can see an object related to each marker. And in our timeline, if we go ahead and zoom in, we can also see our keys. We can use Motion Builder's timeline tools here. Basically, we can select all the objects, and then by clicking on a key and holding shift and clicking on another key, we can select a range, and we can use that as a method to basically delete out ranges and move ranges around in this timeline, and that way we could clean up any parts of the animation that we don't want. As previously in Cinema 4D, there was a period of time where my face was just frozen, and then what I was trying to do is I was actually trying to capture a zero pose, which is going to be important. We're going to need a zero pose in Softimage in order to, or basically a neutral pose like this, to basically map our face. Anyway, once we were done editing all our keyframes here, we would do a motion file export, and we would save to Vicon C3D. And that would pretty much take care of our workflow for exporting out a C3D file from Breako Pro Face. Now in Softimage, we could load that file up, and we would see the exact same data we pretty much saw in Motion Builder. As you can see here in Softimage, I've unloaded Testa's face. That's because in Face Robot, in order to create the files we need to actually have an empty scene. So right now what we're going to do is we're going to go ahead and import, or rather we're going to go to our mocap button here in Face Robot underneath our tools, underneath Face, and we're going to load a C3D file. And using Windows Explorer, we can basically come in here, and first we can go ahead and get our file off our network. So we're going to go ahead and drag from one window, Explorer's window, to the other Windows Explorer window to basically get our profile, to get our C3D file that we had. This is our Faceshift performance. I saved out the performance itself just in case we decided we wanted to load that performance back in to Faceshift and then re-export it out. And we also have the WAV file so that we can synchronize our audio and our NLE a little bit later down the pipeline. Alright, so we're going to go ahead and use Windows Explorer to copy this address. And we're going to go ahead and paste that address here. Do a Control V and hit enter, and that'll put us directly in the folder that we need to be in to get this file. Alright, so once we do that, if we go ahead and hit our S key and go ahead and use our translate tool to translate up and our zoom to truck in, we can see that we get a lot more data out of Faceshift. In fact, if we rotate the face around and about there, we can actually see our actual face. What's really great about Faceshift, markers wise, is all these markers actually share the exact same name that they need to share in Softimage. If we click on a marker and then look here in this little in this little Softimage window we have here, we can see that we selected the object called R eyebrow end. That actually matches the naming convention for Softimage's markers. So now we need to create a name map, and basically we need a name map that matches this face. So what we can do now is we can click on, say, the nose bridge, and then we can find our nose bridge here in Softimage. And actually what we can do, when we click on the nose bridge, it looks like it actually adds whatever we had selected. So what we can do is we can go ahead and try to find the nose bridge, which is here. And then we can click nose bridge and basically make that the nose bridge. And then we can go ahead and try to find the left forehead. That's the right forehead. It's the left forehead, and click that. And because this is, I assume, if I had to make assumptions, I'd say because we made this a symmetrical face initially. No, that can't be right. But it's a possibility because it's looking for symmetrical markers. That's why it's able to find the right marker. Either way, it automatically loaded up both markers, which was great. Let's go ahead and try to find our puffer controls. And basically what we can do is we can move this kind of sort of out of our way. We can go ahead and cover up that area there. And we could just basically go through our controls, really. And okay, we got the right eyebrow in, so we can go ahead and try to find the right eyebrow in this list. And we can basically go through our controls one by one. And we can start to fill out our name map. And so I'm basically going to go through and I'm going to fill out all of these controls and basically create this name map. And I'll meet you guys back on the other side. Alrighty, so I'm done picking, and as you can see, pretty much got everything. The only thing Faceshift didn't provide us was tongue controls. If you want tongue animation, I don't know what to tell you. Haven't found a tool quite yet that'll allow me to pick up tongue controls, but then again, playing around with that, using some controls, some joint controls in Cinema 4D is not very difficult at all. So it's one of those things, kind of like controlling the head rotations, where you're going to, or controlling the eye movements rather, something that you're probably going to want to do in Cinema 4D anyway. So anyway, we're going to hit save and basically save this name map out. Now this name map needs to be saved in the same place that all our face capture is going to go. And basically call this Eldarin nmap. This is going to be the name map for Eldarin's control. Well, this is going to be the name map for any face capture that comes from Faceshift. So actually, this could technically be called Faceshift name map. This name map pretty much will allow us to use any Faceshift capture that we save the same way we saved in this particular tutorial. And pretty much all our Faceshift capture is going to follow that convention, so we're good. Alright, now the face map is something different. The face map relates specifically to a particular actor's facial expression. So this is where we're going to need to find a neutral pose. Basically a pose where I kind of sort of had my mouth closed. Or had just a nice neutral expression. So looking at my Faceshift recording off to the side here, I found that frame 639 I had my mouth closed and I was basically in a neutral expression. Were I to record this again, what I would do is I would create a neutral expression by just, you know, having a neutral facial expression for maybe the first couple of frames of animation, or I would create an animation that basically had just me in purely a neutral face pose. That way I could use that to create my face map. But in this particular case, we're going to go ahead and bite the bullet and use frame 639 as our face map. So we'll go ahead and create the face map, and we'll save this as Eldarin face map. And like I said, for every actor, their neutral pose is going to be different. Their motion capture data is going to be different. You're probably going to want to save different face maps. So click OK. And so now we're back in test as file. Alright, so over here in our library here, in our stage 5 act mode, we can also go into tune mode, stage 6. We can actually pretty much at this point in the solving process switch between act and tune. And tune will allow us to mess with our maps, our regions, and we'll basically be able to paint in our weights and mess with our wrinkles, create wrinkle areas to make the maps, to make the face look a little bit better deformed. And we'll basically be able to correct any issues we have with our mocap. If we go ahead and apply a range of motion in act mode, we can actually see now how her face reacts based on our initial weighting. See how her face reacts with the wrinkles that we define in tune mode and all that. So we can see, of course, we have some unnatural motion, unless we're trying to create a sort of cartoon aesthetic, or we're trying to create a specific aesthetic. But if we're trying to create a very realistic aesthetic here, we can see that we have a few issues. We're going to want to work on our chin maps and basically soften that up. I'm not going to do any of that here. This is basically a general overview. But I will be creating an advanced tutorial where we're actually going to go ahead and go into tune mode in FaceRobot here and actually really clean up these maps. The reason why we created our own motion was because now we can click on this ellipse here, and we can actually come into where we saved our files, and basically we saved our files and our name map and our face map all in the same directory. And basically what happens is this library will look in that directory that we define, and it'll look for a name map in here, and it'll look for a face map in here, a face map and a name map. It'll look for these, and it'll use those as a method to be able to allow us to look at our face capture. So anyway, we're going to copy this directory. We're going to paste it here and do an enter. Now it'll take us, it did not take us to the directory like we wanted to, but we can actually probably paste it here. No, can't do that either. We might actually have to do this manually, which is not a problem. We know exactly where that file is. It's in our documents. It's actually not in our documents, it's in our pictures under CG, under 3D modeling, and under Testa. And then in here I've actually created a new directory called facial capture. This will basically hold all our Softimage facial capture data. We could create separate folders for each actor, so that each actor's name map and face maps are all in their own directories. We're going to go ahead and select this directory, and with this directory selected, we can see that we have our Faceshift test popping up here in the Faceshift motion dialog here. We can go ahead and apply the motion. And thanks to our name mapping and our face mapping, we can actually apply that data now, and we can actually see our own motion here in Faceshift driving our face. And as you can see, you're getting quite a lot of expression out of that facial capture, a lot more than you got initially from Breakle. And this is the power of FaceRobot. We're getting so much expression. There's so much cheek movement going on, and eye movement. We've even got quick blinks. I mean, we're basically getting a fully realistic, very accurate facial deformation, and we only really had our actor sit down for maybe 3 minutes recording, and we're getting this all with Xbox 360 Connect. Now, bear in mind, with the Faceshift capture workflow, you're going to want to use the Mdd drivers, which means you can't run Faceshift on the same computer that you're running Breakle Proface, because Breakle Proface uses the Connect SDK drivers, and you'll break Breakle Proface if you install those drivers and the Mdd drivers together on the same computer. That's why I had to use a separate computer. Also, the Mdd drivers are required for Faceshift for you to be able to get to that tracking point. I've noticed with the Connect drivers, with the Xbox 360's Connect, that when you try to get near to the camera and you try to use that green and red bar that I was talking about in Faceshift, when you try to get near to the camera doesn't really have the ability to be able to really track your face really close. So ultimately, you really don't ever get a track. It can never find your face, and you can never actually really create your animation. The OpenKnee drivers have the ability to let you get in really close to your camera and basically track your face. I hear with the Windows Connect, the Connect for Windows, that's not an issue. You can use the Connect SDK drivers with Faceshift, and the Windows Connect actually has like a near mode driver built into it with the actual SDK, and it actually works. So that's a solution if you want to actually run Braco Pro Face, Braco Pro Body, and Faceshift all on the same computer, and you only want one production workstation. That's pretty much your solution there if you need all three programs. Alright, so with this facial animation put together, we can now work on exporting it out to Cinema 4D. Alright, so to do that, all we have to do is go to our Import Export tab here, and we can generate a point oven cache. Now, the Mdd format comes from Lightwave, and it was basically a format created to allow vertex points and their animation to basically be saved and used across the industry. I think it was initially created by Lightwave for Lightwave, and then everybody picked it up because it was such a great format. We can use Mdd files in Cinema 4D, not directly, but there's some pretty powerful plugins that we can use to actually read that format in and basically apply it to the same head mesh that we sent out of Cinema 4D. So anyway, let's go ahead and generate our point oven cache of this animation, and we'll save this. Let's see, we don't really have a directory for this. But because of the workflow that I use in Cinema 4D, I would probably save this in OBJ directory if I were exporting out OBJs. Surprisingly, we haven't exported out of OBJ yet. That'll change when we get into our ZBrush workflow. But for now, I'll create a OBJ directory, and I'll save my MDDs there. And it's going to go through and it's going to cache each frame of animation's vertex data, the vertexes as they move and as they deform. And it's going to give us a point cache that we can load up on our character. Basically in Cinema 4D, this will pop in as PLA data that we can use with a point oven. Alright, so we're going to let this go through, and when we come back in Chapter 6, I'll show you how to import this into Cinema 4D, and we'll see what workflow we can use in there to go ahead and reattach the head to the body. So see you guys there.